Okay, so first off, we're going to activate this. And so the electrons on the oxygen are going to be pushed over. And this is therefore going to go out and it's going to grab a hydrogen because this needs to have, this positive charge needs to be resolved. And then we're going to get this guy. So we have a double bond oxygen with a positive charge. This is going to make the alcohol able to come over and attack, leaving us with this molecule. And as the first step says, we only added a catalytic amount of sulfuric acid. And so the conjugate base is going to come over and it's going to deprotonate the oxygen, because it wants to be neutral. Then for the second problem, we have our organolithium, and this is almost like a carb anion, so it's really negative, and it's going to go out and find this positively charged carbon doubly bonded to an oxygen, and it's going to attack here, pushing the electrons up onto the oxygen. Then the oxygen, we're now in neutral conditions. Before we were in acidic conditions because of the sulfuric acid, and so the electrons are going to be pushed down to make a double bond, kicking off the OMe. Then once again, our organolithium, this is a partially negative charge, is going to go out and attack our partially positive oxygen, or carbon. It's going to push those electrons up, and then finally we have our negative oxygen, and we have an acidic workup. So now we're back into acidic conditions. So it's going to go and grab that hydrogen off of the hydronium ion, and then we have a deprotection of this alcohol. So this oxygen is going to go, once again, grab a hydrogen, making this positive. We have an assisted leaving, and it's going to go and make a double bond, kicking off the OH group. And we're left with this molecule. We have our unprotected alcohol, and now we have our starting material once again.